Hey everyone, we're going to take a look at number 6 in section 4.1. Going to estimate the change in y, right, using differentials. We're given this as the function y. The value of x, or a here, is 1. So this is the value of the independent variable that we're going to estimate the change in y from. And the dx is 0.01. And we're to give our answer to 4 decimal places. Okay, so how do we approximate the change in y with the differential? Well, the change in y is approximately dy being the differential, which is just f prime of a times delta x, which is really the slope of the tangent line times the change in x, right? So basically, again, the derivative, remember, is the slope. So what we're doing is we're estimating this change in the function by the tangent line. Right. So, I mean, I don't know exactly what the graph looks like near x equal 1, but let's just suppose the graph looks something like this. And then at, grab another pen here. So at x equal a, what we're doing again here is we are using the tangent line. And what's the tangent line going to look like there? Well, if we were to sketch the graph of the tangent line, right, it would look something like what? Just touching the graph at that point. So approximately maybe like that. There's our tangent line. So what we're saying is for values close to a, if you look at it, the graph of the function and the graph of the tangent line are essentially the same. They're very close to one another. Obviously, as we get further away, there's a difference. So whatever that delta x is here, change in x is 0.01, which is really the same as the delta x change. Let's just make it here so that this right here would be the dx, which again is the 0.01. And so what we're saying is we're trying to estimate the change in y, which would be the value of the function at a, right, is the, whatever the y coordinate of this point is, the height of this point. And then if we look at a plus delta x, or a plus dx, which would be 1.01, right, in this case, at 1.01, we can also find the y value there. So the difference between the heights of these two, that's the change in y, right? This is the graph of the function y equal f of x. So what we're going to do is we're going to approximate that by the change in the tangent line. So going from this point to this point, here is the dy. And of course, this is the delta x, or dx. And notice we know the slope of this line is f prime of a, right, the derivative of the function at a. And so since the slope is the rise over run, if we multiply by the run, the dx, we're going to get this dy. In other words, dy is f prime of a times dx. Okay, so there's the graphical interpretation of it. Now, obviously, the difference between the y coordinates of these 2 points, that's the error in our estimate. Obviously, as we get further along, that error is getting bigger. But again, close to a, that error is small. And that's the idea, is we're going to approximate the value of the function there. Now, again, this is real important because if you have very complicated situation here, you can greatly simplify things with a linear function. And of course, in the day and age that we live in with calculators, it seems like that may not be a big deal, but there are some very complicated equations and such to solve that the linearization approximation would greatly alleviate some issues there. Okay, nevertheless, it's simply, this problem is just, evaluate this expression for our approximation. Now, in doing that, I need the derivative of the function, and then I'm going to evaluate, of course, a at 1. So I do need to find the derivative of this function. So, again, we're in chapter 4, we're applying the derivative. There should be a point where you're taking the derivative. If you're not taking the derivative, probably something is wrong in all of chapter 4. So we do need a derivative. And notice this is a quotient, right? One function divided by another, which I cannot simplify because the denominator here is not a monomial, but it's a binomial. So I certainly don't want to do polynomial long division. to try and simplify that. So I'm just going to straight up use what rule would I use to find the derivative? Well, I hope you're saying quotient rule. Right, so the quotient rule is what we're going to use. Take the derivative of the top function times the bottom, which is 2 plus x to the fourth, minus the top function times the derivative of the bottom, all over the bottom function quantity squared, right? There's our quotient rule. And so now we want to, of course, find the derivative of 38 minus x to the fourth. Derivative of 38 is 0. Derivative of x to the fourth is 4x cubed. So be careful. It's 0 minus 4x cubed or negative 4x cubed. Derivative here is just positive 4x cubed, right? Derivative of 2 is 0. And now I just want to be careful to simplify, and distribute that through. And I'm going to be careful to distribute this negative through. So you got to do that and this 4x cubed. So I get negative 4x cubed times 2 is negative 8x cubed. Negative 4x cubed times x to the fourth is negative 4x to the seventh. Remember, we add the exponents here. And then here I got minus 38 times 4x cubed. Well, 38 times 4 is 152, so I get negative 152x cubed. And then be careful, there are negative times negative is positive. X to the fourth times 4x cubed is positive 4x to the seventh. So be real careful there. That's important because notice the negative 4x to the seventh plus 4x to the seventh, those will simplify to 0. And then notice these two terms are like negative 8 and negative 152 is negative 160. X cubed. So there's the derivative simplified. I'd need f prime of a. Remember, the value of a was 1. So I'm just going to evaluate this derivative at x equal 1. And when I plugged in, I get negative 160 over 9, right? 2 plus 1 squared is 3 squared. And so now I'm just going to plug in, right? F prime of a is negative 160 divided by 9. dx, remember, we were just given that. That's 0.01. And so I just need to multiply that out. Keep in mind, right, parenthetically, they tell us, be careful to read the instructions. They want you to round to 4 decimal places. And so when I enter this into the calculator, I do, of course, it's negative 160. Okay, I would go ahead and do it times 0.01 and then divided by 9. Just do it that way. And you can see, of course, if I count all the way out there to the fifth, that's four decimal places, right? I'm going to take and round that up because then the fifth decimal place is a 7. So I'm going to round that up since the fifth decimal place is 5 or higher. Okay, hope this makes sense on this one.